The Skull in the Rock by Lee R. Berger and Mark Aronson. Chapter 1. The First Bone. Dad, I found a fossil. 9-year-old Matthew Berger was fossil hunting with his dad when he stumbled and spied a brown rock with a thin yellow bone stuck in it. Matthew was lucky. His father is Professor Lee Berger, a scientist who has devoted his life to finding the remains of our ancient ancestors. They had often gone exploring together in the brown limestone hills and scraggly trees just outside of Johannesburg, South Africa. So many important fossils have been found in this area that it's called the cradle of humankind and is protected by the government and listed as a World Heritage Site. Though only half an hour from one of the largest cities in Africa, the cradle belongs to animals. Visitors are watched by troops of baboons, dogged by scampering warthogs, measured by soaring eagles. The Bergers always bring their Rhodesian Ridgebacks with them in their customized Jeep, since leopards and other predators prowl nearby, and the dogs smell and sense them in time to give warning. On this pleasant August morning in 2008, Matthew called out to his dad and opened a door 2 million years back in time. Someday, Matthew's words may be famous, the way we honor "What hath God wrought?" the first telegraph message sent in 1844, or "Mr. Watson, come here," the first telephone call 32 years later. What he found was that important. But that's not what his dad first thought. Every other time they had gone out together, Matthew found the remains of ancient antelopes, fossils that are quite common in the area. As Dr. Berger came closer, Matthew could tell his dad assumed it was just another old antelope and was trying to be nice by pretending to be interested. That is exactly what Dr. Berger was thinking, until he was about 15 feet from his son and could focus. Right then, just at that precise moment, he froze. His world went black and white. Time stopped. Matthew was holding a gift from the past so precious, almost nothing like it had ever been found. And the one person in the world who knew that for sure was Dr. Lee Berger. For the fossil was a clavicle, the thin connecting bone across the shoulder that humans and our ancestors share, and that athletes in contact sports sometimes break. The bone is so fragile, not one of the famous skeletons of pre-humans still has a complete one. Yet when he was a graduate student, Dr. Berger had written his PhD thesis on just that bone, and 3 others that would become important in this story. The bones that make up the upper arm. Because Matthew had trained his eyes, he recognized a fossil. Because his father had studied that part of the body, he realized the treasure in his son's hands. For Dr. Berger, it would have been enough to find that one special bone. But the clavicle was just the beginning. It was the rabbit hole beckoning Alice, the wardrobe flung open to Narnia, the first clue to what is becoming an entirely new way of understanding human evolution. It's easy to envy the Bergers, to wish you or I had the chance to find the bone, which turned out to be part of a nearly complete skeleton of an entirely new species, Australopithecus sediba, previously unknown to science. But as Dr. Berger says, that's getting it totally wrong, because the most important thing about the find is the doors it opens for the next new discovery. Every door leads somewhere, even those that seem closed. This is what Dr. Berger's own life story told him. Chapter 2. Seeing the Anomaly. If you were looking for young Lee Rogers Berger back when he was growing up in the town of Sylvania in Screven County, Georgia, you would have needed strong lungs. When he didn't absolutely need to be inside the house or at school, he was sure to be outdoors. That's the kind of boy he was. No shoes all summer long, until he was old enough to follow the seasons through fishing, hunting, and generally just waiting to see what adventure nature would bring. If a farmer was plowing his fields, there would be Lee, scouring the furrows for arrowheads. Put a bow in his hands, and he'd keep practicing until he was state archery champion. Bumping along in the back of the family pickup, in the days when a ride in an open truck meant standing up and holding on, no seatbelts, he had his eye out for strange, or interesting, or injured animals. All this time outside allowed him to collect his scouting merit badges at a good clip, earning his way up to Eagle Scout and to join the 4-H Club and Future Farmers of America. The Burgers were not exactly farmers. His mom was a math professor, and his dad worked in an office. Although they did not have much money, Lee, his brother Lamont, and their parents often moved to Savannah, on the coast, in the summer, then back to rural Sylvania, like many Georgia families at the time. But they were not far from the land either. Lee's dad always wanted to be a geologist, which was one step away from Lee's grandfather, who had lost many of his fingers hunting for oil as a wildcatter in West Texas. Wildcatters are the wiry, tough men who set out on their own with whatever rig they can beg, borrow, or steal to find oil. Black gold. One day, Lee's grandfather showed him a sealed chest. He flung open the lid, and there, inside, were thousands of pieces of paper. Stock certificates from all of the oil companies he had been part of. Each one a dream that had gone bust. Yet he was not bitter. Wildcatters admire a man who has failed many times. It means he has tried and had the guts to go on. Lee's dad decided to put his love of the land aside and provide for his family. But Lee inherited his grandfather's spirit. He loves a grand quest, an all-in roll of the dice. He's that restless boy who throws himself into his current interest until he masters it, but then needs a new goal, a new passion, a new hill to climb. Those who don't know such boys call them easily distracted. Those who do know they are hungry for adventure. As Lee wandered the fields and pine forests of Screven County, he practiced reading the land. It takes 2 skills to be a wildcatter. You have to know the terrain, and because you are so good at that, you train your eyes to notice what is different, what doesn't fit, what Lee calls the anomaly. The first anomaly that made a difference to Rod, as Lee was then known, was an animal that spent most of its time underground. Like its name suggests, the gopher tortoise likes to dig a snug home for itself underground. From his perch in the back of a truck, Lee started to notice a bad pattern, an anomaly. 1, 2, far too many dead and injured gopher tortoises. Why was that, and what could he do about it? Some deadly snakes are happy that gopher tortoises carve out nice homes for them. But a human family is not eager to have their kids playing near snakes, and one quick way to avoid that is to send gasoline down any holes you see. And if some tortoises die along with the snakes, well, that's just one less hole digger to worry about. Worse yet, when pine forests were harvested for timber, the burrows dug out by the tortoises were destroyed. Lee had to do something, but what? He convinced his parents to turn part of the land where they raised pigs and cows into a refuge for gopher tortoises. Now every jolting ride in the pickup was a potential rescue mission. Word spread of this new idea, a nature preserve founded by a teenager to save a local animal. And in 1984, Lee was named Georgia's Youth Conservationist of the Year. As the honoree, he got to speak to the state representatives about the gopher tortoise. Today, while the animal is threatened, and it is still legal in Georgia to send gas down a burrow to clean out snakes, the gopher tortoise is the state reptile. Observe, notice, act, change the world. That is what Lee's childhood taught him. But how did he get from Georgia to South Africa, and from tortoises to fossils? Through the covers of a book. Chapter 3. Lucy. On November 24, 1974, at the end of a morning of fossil hunting in Ethiopia, a young paleoanthropologist named Jonald Johansen followed a hunch to look in one more spot, and saw First an arm bone, then a leg bone, then ribs, and then it hit him. There in the earth nearby was the entire skeleton of someone, which turned out to be Lucy, an ancestor from 3.2 million years ago. After carefully describing his find to the scientific world, Johnson told his personal story to the general public in a book simply called Lucy. Lucy changed Lee's life. In his typical way, Lee had been on a roller coaster of ups and downs. He got into Vanderbilt, a fine university, on a Navy scholarship, then dropped out that he realized he was never going to be the lawyer or politician his parents imagined. He experimented with working in TV news and even became a national hero when he rescued a woman who was drowning. But his heart was not in chasing after police cars and filming local events. Back in college, at Georgia Southern, he began to picture himself as a dinosaur hunter, looking for the fossils of the next T-Rex. And then one afternoon at the library, he saw Lucy. Lucy tells the story of how the author found our oldest human ancestor and who she was. From the first page on, Johansson, a serious, skilled paleoanthropologist, talks about training your eye to see what you need to see and being lucky. Training your eye. That was exactly what Lee had learned from his grandfather and had been doing since childhood. And luck? Now that was interesting. Looking for the fossils of our ancestors is like hunting for oil, but thousands of times more difficult. Lee estimates that the odds of finding the bones of our oldest ancestors are 10 million to 1. That is the kind of gamble he likes. As he says, I always want to push boundaries. And that is not just because he likes to take big risks, though he does, but because he wants to make big discoveries, and there is no larger challenge than helping to solve the mystery of human origins. How and why did we evolve from apes? Which came first, walking on 2 legs or having a hand that makes it easy to use tools? What about our brains, which are much larger than those of chimps and organized in different ways? How did that happen? Reading Lucy gave Lee a vision of his life goal, hunting for the most crucial and precious, clues to the story of humankind. But Lucy was also a warning. Fossil hunting requires the perfect blend of knowledge, guts, and luck. Lee had found what he loved, the most difficult mystery of all. Chapter 4. The Hunters Set a Trap. Gladysville Cave, Cradle of Humankind, South Africa, 1994. Lee was in his favorite spot, a cave he had been exploring for years, even when he had to dodge prowling leopards, when he glanced up at his audience. A troop of vervet monkeys was seated at the edge of a cliff opposite the cave, amusing itself by watching him. Suddenly they were alert. Vervets have an alarm cry that they teach their young. A sound so carefully passed on, some scientists believe it's a primitive form of animal language. The monkeys began screaming. Up there in the sky was danger, a black eagle. The monkeys rushed away from its path, straight into the trap. The first eagle had been a decoy, and the monkeys fell for it. For now a second eagle, the real hunter, swooped down from the opposite direction and instantly picked off an adult male. Lee had never seen an eagle take on an animal as large as a monkey. He jumped up, rushed to his car, and sped off to the nearby nest to see what would happen next. There lay the scattered bones of the 2 hunters' many kills, some as large as a baboon. His mind began spinning, right back to the reason he was in South Africa, and a key discovery made there in 1924. Back in the 20s, miners searching for limestone were still blasting away in the area that is now the cradle of humankind. One day, as they worked in a mine outside of a place called Taung, the place of the lion, they noticed the pile of bones in the rubble, including a tiny skull. A miner was smart enough to put it into a box and send it to Dr. Raymond Dart, a scientist at the University of Witwatersrand in Johannesburg. Dr. Dart figured out that the skull belonged to a child of about 3 years old. Then he came to the revelation. He saw the opening for where the spine would have gone, fit an animal that walked on 2 legs, not a chimp swinging from the trees. Dart announced that the Taung child was the fossil of a previously unknown animal fitting between chimpanzees and humans. He named a new genus and species, Australopithecus africanus, the southern ape of Africa. That was the first human ancestor ever discovered in Africa. And while for decades, experts in Europe refused to believe Dr. Dart, the Taung child is now accepted as one of the most important fossils ever found. Indeed, after a terrifically lucky first day on a dig in Kenya, where he found a hominin fossil, Lee had come to South Africa first to study and then to follow in Dr. Dart's footsteps, continuing the search that had begun with the Taung child. But there was always a mystery about the skull and the bones found with it. The Taung child was found with many mammal remains, most of them small, but no other hominins. Why? Dr. Dart believed that this was the home site of killer apes who left the bones of their victims. Later scholars assumed large cats had once lunched there, but the skeletons did not match the usual collection of leopard prey. Who killed the Taung child? As Lee's eyes ranged over the nest of the 2 eagle hunters, he recognized the skeletons. They were very similar to those found near the Taung child. In fact, the damage on the bones of the eagle's prey was the same as that on the fossils from Taung. Could an eagle have both killed and managed to fly off with a 3-year-old Australopithecine? Lee and his colleague, Dr. Ron Clark, wrote a paper suggesting the idea. Many scientists were skeptical. They just could not picture one of our ancestors as the victim of a bird feeding its own young. The controversy over the eagle theory was hardly Lee's only problem. In fact, by 2000, it looked like his entire dream of following in Johansson's footsteps was doomed to failure. Chapter 5. What is right in front of my eyes that I'm missing? Lee first began working in the Gladysville Cave in 1991, and soon found teeth and other traces of ancient hominins. Terrific! This was the first early hominin site found in South Africa since 1948. Indeed, when he won the National Geographic Society's first Research and Exploration Prize in 1997, Lee used his award money to carefully survey the region, looking for other possible fossil sites. But by the beginning of the new century, it seemed his luck was failing him. As of 2000, Lee had only located a few fossil fragments, some more Australopithecine teeth and bones to add to South Africa's chest of ancient treasures. And then, an important scientist, one of the giants in the field, published an article arguing that there were probably no new fossil fields to be discovered, and that the remaining sites were rapidly being exhausted. The field was dry, and would only get drier. It was hard to argue with the article, especially when Lee's own expensive survey failed to yield any important new discoveries. He was right back where he had been when he'd left Vanderbilt, as adrift and depressed as only a passionate explorer can be when he cannot find the next adventure. Lee's lifetime quest was over. Since no one was going to sponsor him to go out into the field was changing. Computer technology for examining the remains already found seemed to be the future for the science. From now on, research into human origins would take place on screens and in gigabytes of digital memory. The door to the great outdoors appeared closed. Restless, Lee looked for new challenges. He filmed a TV documentary series on exploration. Armed with his camera, he tramped through South Africa's great game parks and then wrote a guidebook for other visitors. He became a master diver, so that any vacation would give him a chance to range around the ocean floor. But even these efforts created some flack. A TV special built around discoveries he made diving on Pacific Island annoyed a small but vocal group of his scientific peers. And then in 2005, Lee read an article. 10 years after Berger and Clark proposed the eagle theory, scientists at Ohio State University set out to study African crowned eagles. They learned exactly how eagles hunted, how they flew off with their supper, and what the resulting collection of bones looked like in a nest. Every single skull held similar marks, notches cut by sharp talons, and a probing beak into the eye sockets. Lee rushed to his office, opened the strong safe that guarded the Tong child's skull, and carefully examined the fossil. The exact same markings found in modern eagle kills were clearly visible inside the eye sockets of the tiny child. Proof. Case closed and opened. For 80 years, they had looked at that very skull and not seen what was in front of their eyes. They had missed the anomaly. What am I not seeing, Lee wondered. What is right in front of my eyes that I am missing? Everything, as he would learn in the last days of December 2007. Chapter 6. If you look with new eyes, you see new things. Lee is like so many of us. When he turns on his computer or tablet, he is eager to try out whatever new programs and apps it offers. As 2007 came to a close, he noticed an option he had somehow missed: Google Earth. Of course, he had to plug in his address and see his street, his home, his office at school. That was fun. What next? For 17 years, Lee had explored the brown hills of the cradle, following in the footsteps of one great scientist after another, back to Dr. Dart himself. There may not be a single area on this planet that has been as closely examined for possible hominin fossil sites. Could he look at the cradle through Google Earth? You can't write in, second scraggly tree from the left near where the antelope hides at midday as a search question. But the survey Lee had commissioned with National Geographic prize money meant he had GPS coordinates for the hills and valleys he knew so well. Here was Gladysville Cave, where he had seen the eagles kill a monkey. There were the Sterkfontein caves that had yielded Littlefoot, the fossil hominin Dr. Clark had been studying for more than a decade. So far, so good. But what was this? As Lee shifted from plugging in larger features to smaller sites, what he was seeing on his screen did not look right. What should have been a hill was a stream. What should have been one side of a cave was another. The anomaly alarm bell started to ring in his mind. Half of the problem was easy to solve. It turned out that the global satellite positioning system that Google Earth used deliberately had small errors in it. The U.S. Defense Department, that had created the images matched to GPS coordinates, did not want to hand potential enemies precise information they could use to launch missiles. Now, Lee Berger, Eagle Scout, explorer, scientist, would have to come to his computer and slowly, carefully, figure out how much he had to adjust the image and the coordinates so that a cave appeared where it was supposed to be. He had to look and look and look again at the cradle, but at a different angle, not from the ground, but from the eye in the sky. Looking down, oh so carefully, examining the Google Earth image, he began to pick out features he had not noticed in 17 years. Looking with just their eyes, he and his colleagues had located some 130 caves and 20 potential fossil sites. But what was that cluster of trees hiding? Was that a trace of a seam? A fault line? If so, might there be caves along it he'd missed? Every new depression in the earth could be a collapsed cave, a place where fossil bones might be covered, caught, saved from harm. By the middle of 2008, he had located more than 600 caves and more than 30 new fossil sites. He and generations of previous scientists had been blind, seeing only what they expected to see. Hidden in the dips and folds of the cradle were possibilities beyond imagining. Now all he had to do was go out and explore them. Where to start? Since Lee was looking for new sites, he thought he had better begin in a new spot. So he went out in the field as far from Gladysville and the other familiar places as he could go. One more mistake, which he calls backyard syndrome. You don't expect to find anything in a new place you know very well. But why not? The very fact that it is so familiar may mean you hardly notice it at all. You see what you remember and expect to see. Slowly, Lee moved back, closer and closer to home ground. He loaded his dog Tao into the Jeep, and sometimes brought Matthew or his teenage daughter Megan along, or even a friend to keep him company, and went hunting. May turned to June, June to July, July ebbed away. On a screen, he noticed a cluster of trees in a place he later decided to call Malapa, meaning homestead in Sesotho, a local language. A short hop from Gladysville, trees and clumps are often a sign of a collapsed cave, but he had explored this area back in 1998 and was sure it held no secrets. But then, on August 1st, he noticed a track in the ground, a sign that miners had blasted the area looking for limestone. Walking that track, Lee found evidence of 47 previously unknown caves. He returned 2 weeks later with Tao, Job Ki Bi, a postdoctoral student from his lab, and a guest. And it was there, walking just outside the circle of trees, that Matthew stumbled and called out, "Dad, I found a fossil!" Chapter 7. The Answer. When Lee turned over the stone block, he noticed a jawbone with a tooth. Back in the lab, they found even more. The upper limbs of a partial skeleton. He could not wait to get back to the site, but he needed permission from the government to actually dig. Finally, on September 4th, Lee and 13 colleagues returned to Malapa to examine the ancient cave. The team arrived very early in the morning and in high spirits. One after another, they tried to figure out where Matthew's block came from, and thus where there might be more fossils. But as they broke for tea at 10 a.m., they had nothing to show for their labors. Could it be that the stone had been blasted out of one of the other 46 nearby caves, one destroyed by the miners? The sun was rising, clearing the shadows from one wall of the newly excavated pit. Lee spotted a bone. It was a humerus. Yes, one of the same bones he had studied for his PhD. Then he saw a second, a scapula, another of the bones he had studied. He couldn't believe his luck. He stepped down into the pit, and as he placed his hand on the wall, 2 teeth fell into his hand. Lee was falling down the rabbit hole into Wonderland. Matthew's find, it would turn out, was a bone from a young male, somewhere between 11 and 13 years old. We can estimate his age because we have since uncovered very nearly his entire skeleton. We can see where his bones were still growing, and his teeth were erupting, but we will soon do better than that. In France, one of the most expensive pieces of equipment in the world, a synchrotron, is analyzing his teeth. By counting the microscopic layers of enamel that grew when he was alive, it will give us his exact age in days. A nationwide contest held to give the boy a name was won by Omfentisse Kipile, a girl who suggested Karabo, the answer. Karabo was about 1.3 meters or 4.3 feet tall, and weighed somewhere between 50 and 45 kilograms, or 66 and 100 pounds. Weight is harder to estimate than height, since all of his fat and muscle are gone. But because he was still growing, he would eventually have been taller than a second homonym Lee found at Malapa. The second skeleton is an adult female. Could they be related, even mother and child? There is a remote possibility that we will be able to recover DNA, but we cannot wait for that slim chance. So experts are trying to invent new ways of determining how closely related the 2 skeletons may be. Scientists have never had this problem before because no 2 such complete ancient homonym skeletons have ever been located right next to one another. It now seems very likely that fossilized skin can be made out next to the surface of some fragments from both skeletons. We have never even been close to recovering that before. And these are just a few of the vistas Malapa opens for us. Think of how unlikely this is. Before Matthew found Karabo, outside of Lucy, we had almost no nearly complete fossil homonym skeletons that could be dated back to before 1.8 million years. And none from the crucial crossing period around 2 million years ago, the time between Lucy and our immediate ancestor Homo erectus. Lee himself had spent 17 years and found just a few fossil fragments, which is more than most experts find in their whole lives. Now we have 2 marvelous skeletons to examine, and soon we will have more. Lee and his team have found treasure beyond anyone's wildest pirate dreams. We now know that there are fragments of at least 4 other homonyms at Malapa. Determining when they were alive is another kind of detective story. But we have clever scientific tools to help us. We have learned how to read the secrets of the rocks that surround the Sediba fossils. Chapter 8. Dating Karabo. Why are the fossil bones of our ancestors so rare and so important? Starting from the time when Karabo was alive, all of the forces of nature work against us. Anyone killed by an animal would have had his or her skeleton pulled apart and gnawed. Even if a person died in a safe spot, there is every chance that the following endless centuries of wind, rain, rock slide, flash flood, as well as human construction or destruction, would have destroyed the remains. It is only by great fortune that any bones survive as fossils. That is, the skeleton is encased in soil, and over time, minerals replace the bone, preserving the exact shape of the original. So scientists have to go to places like dry riverbeds and ancient caves where fossils may have survived. They have to read back through the soil like a detective in a novel to figure out what kinds of land formation, sealed by luck and time, might hold a secret. If we start from the present, there are a new set of challenges. A fossil bone does not come with a tag. The scientist needs to determine how old it is and what it is. Neither of these questions is easy to answer. Archaeologists who study the history of human civilization are lucky. Anything that was once alive has the element of carbon in it, which we can use to figure out how old it is. But that method is only useful within about a 40,000 year span. Lucy, for example, was born over 3 million years ago. For fossils that old, carbon dating is useless to us. The most obvious way to date a fossil is by using knowledge of the land. Lower seems to mean older, since over time, one new layer of rock or soil or plants piles on top of another. But as anyone who has ever dug at the seashore knows, a sudden slide can tilt that layer cake. And that is not to speak of earthquakes, cave-ins, or even disturbances caused by burrowing animals or spreading roots. Even if a bright scientist can line up the order of soil deposits and figure out which one originally held the fossil, that gives us a sequence, not a date. To work that out, scientists need a new set of clues. One way to date something you find in the earth is by looking at what is near it. If a fossil is surrounded by the remains of ancient plants or animals, you research to find when they were alive. This kind of comparing and estimating is called relative dating, because it yields a general range of dates but not specific years. To get one step more precise, what scientists call absolute dating, you have to use what we have learned about the inner life of rocks. Since the 1960s, we have developed more and more clever ways to read the stories told by the radioactive elements trapped in stones. For example, if a rock formation contains lead, we are lucky because we know a lot about how lead is formed. Lead comes in 4 types, or isotopes, and 2 of these are created over millions of years as the element uranium slowly decays. Measuring how much uranium is left and how much lead we have now tells us the age of the rock. Uranium-lead dating. We have learned that the Earth's magnetic poles periodically reverse. What is now north was south. If there are iron particles in the soil, we can measure which way they are oriented, toward current or earlier magnetic poles, and compare that to a carefully mapped timeline of magnetic reversals, like matching up lines on a barcode. Paleomagnetic dating. By greatest fortune, the Sediba fossils rest between 2 layers of stone, which allows us to use both the uranium-lead and paleomagnetic dating methods. The orientation of small particles similar to iron filings fit one particular reversal of the Earth's magnetic poles that took place between 1.977 and 1.98 million years ago, a tiny 3,000-year window. We know exactly when Sediba lived, but what kind of creature was it? More human? More ape-like? How can we tell? We are back to comparison. Only this time, the game is more complex. We know a great deal about modern humans and about our closest living relatives, modern chimpanzees. But what happens when you find a bone that has human-like qualities? For example, a body built to walk on 2 feet, or a hand with an opposable thumb, and chimp-like qualities. For example, a small brain or conical-shaped chest. And what if many of these bones are fragmented, distorted, or broken? The scientist is faced with the most taxing jigsaw puzzle. He or she has to look at every other similar fragmentary fossil and try to line them up into a story of before and after. At one time, scientists assumed they could arrange the bones in a clear ladder. Chimp, chimpish animal that walked upright, walking on 2 legs with larger brain, human. But so many different and puzzling branches of ancestors have been found that no one can say for sure which led to what. We now believe that nature tried all sorts of experiments in the millions of years during which troops of animals that walked upright on 2 feet lived in Africa. Making sense of this wide variety of bones has churned up so many more questions than answers that even the terms are changing. We used to speak of hominids, the larger group including us, our ancestors, and our primate relatives. Now Lee and many other scientists prefer to say hominins, meaning only humans and our human-like relatives, treating this cluster as distinct from the chimpanzee, gorilla, bonobo, orangutan, and gibbon group. But if experts argue over how to lump or split clear human and clear non-human, Think of how difficult it is to map out what once lay between us. Matthew's find adds one huge new piece to the puzzle. Chapter 9. The Source. How did Karabo and 5 others die in the cave at Malapa? Lee named the discovery Australopithecus sediba. Sediba is kind of a pun. It means wellspring, because, very likely, millions of years ago, the cave was a sort of natural well. The hominins probably fell into it searching for water. The boy's arms are fractured just where they would be if he had been trying to break his fall. The chemistry of the wet soil was such that as the bodies decayed, the mud quickly hardened into a kind of concrete, guarding the bones as they turned into fossils. But another word for wellspring is source. Of water, yes, but perhaps in another sense, of us, of human beings. What is Sediba, and what can it tell us? Primates travel in groups, like the baboons that greet visitors to the cradle, as indeed we tend to live in families. Most probably, Karabo was with his relatives, making his way through the stands of large yellowwood trees, in a dangerous and dry world. Malapa holds the bones of saber-toothed cats and hyenas, carnivores who may have also fallen while desperate for water. As we know from the Tong Child, killers would swoop down from the skies. Yet Sediba had immensely valuable traits that separated it from chimpanzees. Sediba's hand is hauntingly similar to that of a modern human's, with a fully opposable thumb. A chimpanzee's hand is excellent for grasping and swinging from trees. Sediba's hand could hold and use small objects. Sediba's head is tiny, and it held a brain that is just on the edge of the chimpanzee range in size. But Sediba's brain is organized differently from that of a chimpanzee, and the areas that are bigger might have to do with the language and more complex problem solving. Surely Karabo's group made sounds, not words or sentences, but perhaps calls, or even hand gestures that served as a form of sign language. And finally, Sediba had odd feet. While his heel is quite different than ours, he probably did not have a grasping toe like an ape. His body was adapted to function in trees, but also to walk on 2 feet on the ground. The picture Sediba paints is one of mixture. Sediba had the long arms of an ape, with a hand more human-like than other hominins, even some from later dates. It had that tiny brain, but the relatively small difference in size between Karabo and the adult female seems similar to humans, as is his rather small canine teeth. He was not built to terrify other males. Indeed, the structure of the bones near his mouth suggests that, unlike chimpanzees, he could smile. When Lee describes all of these intriguing and puzzling traits, you hear something different in his voice. Sure, he's a scientist, and he is an able public speaker who has outlined all of this many times, to everyone from Nelson Mandela to Jane Goodall to Bill Clinton. But there is a tenderness in his words, something that even sounds like love. He loves this strange creature his son found in the rock, this gift from an ancient times given to him by the gopher tortoise, the eagle hunters, and Google Earth. He loves it perhaps most of all because Sediba itself is, well, an anomaly. Karabo's teeth are so well preserved, we were able to get a very good picture of his diet. Almost all primates eat whatever is around them. Indeed, one line of hominins is known for its large teeth, designed to crush anything from meat to tough plants. Karabo ate a different diet, perhaps focused on berries, seeds, fruit, and maybe even bark. Only a few other distant relatives of ours, such as the savanna chimpanzee, are such picky eaters. Anthropologist Jill Pruitt argues that these particular chimps make spears and show other remarkably human traits. Could it be that Sediba also knew how to make tools? Lee Berger, the scientist, says it's way too early to make that claim. But when you look into his eyes, you see a gleam, and you know he is trying out that speculation in his ever-active and lively mind. The more we examine Sediba, the more we realize how little we know, and how much more there is to learn. As William Kimball, a paleoanthropologist at Arizona State University, told National Geographic, Before Sediba, there were only a handful of specimens from that time period. You could put them all into a small shoebox and still have room for a good pair of shoes. Sediba has exiled the shoes and demanded a bigger box. That is what makes the discovery so exciting. It will now be up to the next generation of explorers, perhaps including people who were inspired by this book as Lee was by Lucy, to fill in those blanks. And as we explain on page 59, Lee will help. First, we have to think about how to search. Lee digs things out of the earth, and indeed, Matthew's clavicle was blasted into his path by the miner's dynamite. Yet Lee is intensely aware of the danger of destroying evidence or trampling nature. His wife Jackie is a trained radiologist, and her skill with a CT scanner allows scientists to see and make models of fossils while they are still encased in loose rock. Someday, Lee believes we will not have to dig at all. We will see into the earth without cutting it open. Even his teenage daughter Megan is developing new, prize-winning ways to determine how fast fossils would form at a site like Malapa. We will know more by understanding better how to look. There is a second way that we have to see with new eyes. Unlike other books on human origins, this one does not have a chart showing which led to what, with handy dotted lines spelling out the links. There are many of those on the internet. But as you will notice on page 60, Lee wants us to change the image we have in our minds. Not a ladder leading up, or even a tree with branches, but a braided stream where different species interbred in ways we are only starting to understand. That image of connection, peoples flowing together, happens to also be featured on the flag of South Africa, which brings me to one last meaning of Sediba, the source. South Africa is a very new nation. It only finally freed itself from the chokehold of white rule in 1994. Everywhere you go in and around Lee's lab, you feel the South African sense of pride and ownership. This link to our ancient past is also a symbol of their new beginning. Chapter 10. What if Lee is all wrong about Sediba? I wrote this book after reading about Lee, meeting him, and exploring Malapa with him as my guide. Clearly, it is his version of his past, his discoveries, and their meaning. In general, the scientific community has embraced not only Sediba, but also Lee's approach to studying it. Still, as is usual in science, there are those who express doubt or hesitation about what Sediba means, where it fits into the story of human evolution. And there are scholars who are equally excited about their own discoveries. Dr. Clark, who co-wrote the Taung Child paper with Lee, has spent more than 15 years working on the fossil called Littlefoot. He believes it is the ancestor of those big-toothed hominins. Lee's answer to those critics, and the point of view I take in this book, relates to something else I observed about him in his lab. Lee is a big spirit, a risk-taker whose personality fits the Indiana Jones-style hat he sometimes wears. But he also likes collaboration, the hubbub of a group of peers. That suits science as it is now being practiced all over the planet, where younger experts value collaboration more than, or at least as much as, individual glory. From the moment when Lee saw the bone in Matthew's hands, Lee's policy has been to share everything with the scientific community. Now that more than 85 scientists are working on aspects of Sediba and Malapa, the game is out of Lee's hands. The question is not whether he is right, but what the very best experts, sharing ideas, competing in their interpretations, developing new techniques of inquiry, come to decide. Sure, Sediba has been good to Lee, who is whisked off to all corners of the world to talk about it. But in a way, it is no longer his discovery. He has handed off Sediba to everyone, to you. For just as he was sure, after finding proof of the Taung Child eagle theory, that there were so many other clues all around him, he knows you will see what is invisible to him. And so in this book, he is passing the baton, encouraging you to train your eyes, to walk the land, to learn to see the anomaly, and to make the next key discovery. And because he knows that Sediba is in the safe hands of the scientific community, and that you too will begin your own searching, he is now free. Lee Rogers Berger can go back to doing what he loves, exploring. To make sure that everyone who reads this book can take part in the adventure of science and discovery that began with Matthew and the clavicle, Lee and I have agreed to try an experiment. Every time a scientist finishes working on some aspect of Sediba and announces his or her results to fellow experts in a research paper, We will explain those results to you at this site, www.scimania.org. scimania.org. Anyone who can read this book will know exactly as much about the frontiers of science, about the doors open into human evolution by Sadiba, as the most senior professional scientist. We have agreed to do this so you can join in the hunt, so you can see what we miss, so that you are the next ones to find the next beautiful anomaly.